दोबारा तो तुहाडे सामने आए हैं। इन्हां नूं भावें ऑप्शनल किया गया आ वाले लैक्चरस नूं, बट आई होप कि तुसीं इन्हां नूं सारे दे सारे अटेंड कर रहे होगे ते ट्राई टू टेक मैक्सिमम बेनीफिट फ्रॉम आर लैक्चरस। असीं जिथे छड्डिया सीगा अपने लैक्चरस उत्थों ही स्टार्ट करते हैं। तुसीं जिहड़े साडे पहला ऑर्गैनिक दे लैक्चरस अटेंड किते होणगे या किते सी, उस दे विच असी एल्काइल हैलाइड्स एंड एल्कोहल्स नूं कवर अप किया सीगा। अज असी उसे दी कॉन्टीन्यूएशन दे विच फीनोल्स वाला टॉपिक ले रहे हैं। सो फीनोल्स एज यू नो आर द हाइड्रोक्सी ग्रुप प्रेजेंट ऑन द बेंजीन। आ देखो, जे असी OH ग्रुप नूं बेंजीन रिंग दे उत्ते लगा दिए then it is named as phenol. Not only phenol, this is also named as carbolic acid. So carbolic acid is nothing but a phenol. कई बार यह क्वेश्चन आता है बेटा कि कोई इहो जिहा एसिड which of the following acids does not contains any carboxylic acid group. सो उत्थे नेम हुंदा है एक उन्हां दे विचों कई बारी कार्बोलिक एसिड दा। इसे तरीके की दूसरी एग्जाम्पल हैगी है साडे कोले पिक्रिक एसिड दी। पिक्रिक एसिड इज अ वेरी स्ट्रोंग एसिड एंड इट इज़ अ डेरीवेटिव ऑफ सिंपली अ फीनोल। सो दीज फीनोल्स हुण तक तुसी मेरी इस तो समझ गए होगे कि दीज फीनोल्स एक्ट्स एज ए एसिड, देयरफॉर दे आर very important organic compounds. So let us try to name them first. This is the substitution of a phenol. This is a simple phenol, and when we substitute a bromine on a meta position, then it is metabromophenol. See, this is here, see the cursor, this is what we called as ortho position, this is meta position, and this is para position. Again this is meta and this is ortho. So if bromine is attached on the meta, then we say metabromophenol. If it is on the ortho position, then it is orthobromophenol, and if it is on the para, then we say it is a parabromophenol. Also this metabromophenol can be named as 2-bromophenol. बेटा मैं तुहानूं क्यों नॉमनक्लेचर दस रहा, क्योंकि असी इस दे विच कन्वर्जनस करनियां होंदियां ते जे तुसी कन्वर्जनस दे विच 2-ब्रोमोफिनोल या 1-ब्रोमोफिनोल या मेटाब्रोमोफिनोल इस तरह के नाम नूं इंटरप्रेट नहीं कर सकोगे, दैन असी तुसी उन्हां नूं कन्वर्ट भी नहीं कर पाओगे. सो इट इज़ वेरी इंपॉर्टेंट टू लर्न हाउ टू राइट अ IUPAC नेम or from a name to a formula. So this is a metabromophenols, or this is a first position, second and third 3-bromophenol. Metabromophenols or 3-bromophenol. If it is here, bromine is attached here, then it will be a 2-bromophenol or a orthobromophenol. Similarly, a parabromophenol and a 4-bromophenol. If it is here, then it is, yes, again a metabromophenols or 5-bromophenol, है ना? नहीं, this is wrong. Now we will do the numbering from this side, 1, 2 and 3. So it is again a 3-bromophenol. This is a 2-bromophenol. So 5 या 6 positions असी नहीं देंदे बेटा जदों substituent single substituent होवे. If there are 2 substituents, then we can have to give this. For example, here we have bromine and here we have again a bromine. Then it will be 1, 2, 3, 3,5-dibromophenols. Okay, 3,5-dibromophenols if bromine is attached here as well as here. Similarly, if we have CH3 substituent, then in common we say it is as a cresol, otherwise it is orthomethylphenol. Similarly, this is a salicylic acid, again a very important organic compound used for the preparation of a very known drug named as aspirin. ਇੱਥੋਂ ਦੀ ਅਸੀਂ aspirin ਬਣਾਉਂਦੇ ਹਾਂ, which is I think used in every house nowadays. So aspirin is prepared. This is the starting material of aspirin. ਇਹਨੂੰ ਅਸੀਂ salicylic acid ਵੀ ਕਹਿੰਦੇ ਆ ਤੇ now this will be named as orthohydroxy benzoic acid. Okay, because hydroxy group is lower in the preference order to the carboxylic acid. So if I have to name it IUPAC according to IUPAC rules, then this will be 2-hydroxy benzoic acid. Similarly, catechol, when 2 OH is present adjacently, and if the OH next OH is present to a meta position, then we say it is a resorcinol, and if the 2 OH are present para to each other, then we say it is a hydroquinone. And then see here the OH is present ortho to this benzoic acid, and here OH is present para to this benzoic acid. So it is para hydroxy benzoic acid, or it is 4-hydroxy benzoic acid. So this is the sum of the IUPAC names which I gave you. There can be a different one also which we will use in our subsequent slides. Okay, ਸਭ ਤੋਂ ਪਹਿਲਾਂ ਅਸੀਂ ਇਸ ਦੀ ਫਿਜ਼ੀਕਲ ਪ੍ਰੋਪਰਟੀਜ਼ ਨੂੰ ਪੜ੍ਹਨ ਦੀ ਕੋਸ਼ਿਸ਼ ਕਰਦੇ ਹਾਂ. I will take the preparation afterwards. ਤੁਹਾਡੀ ਬੁੱਕਸ ਦੇ ਵਿੱਚ ਵੈਸੇ preparation ਪਹਿਲਾਂ ਲਿੱਤੀ ਹੁੰਦੀ ਹੈ, then physical properties, but I am taking here the physical properties first. Phenols are polar and can hydrogen bond with water. This is the first thing. Phenol ਦੀ ਜੇ ਮੈਂ structure ਅਸੀਂ ਜਿਵੇਂ ਦੇਖ ਰਹੇ ਹਾਂ, it is like this. मैं phenol बनाया बेटा ਤੁਹਾਡੇ ਲਈ बोर्ड ਦੇ ਉੱਤੇ. So this is the phenol and it is polar in nature. Therefore it forms hydrogen bonding with water, and it goes on. Like this. Similarly, then it go on again. Now since it is a polar, so therefore there will be a delta negative charge on this and delta positive charge on this. That is why it shows hydrogen bonding. But the hydrogen bonding shown by this phenol group is very less, because the size of R, ਜਦੋਂ ਅਸੀਂ alcohol ਦੀ ਗੱਲ ਕੀਤੀ ਸੀ ਬੇਟਾ, ਉਦੋਂ ਤੁਹਾਨੂੰ ਦੱਸਿਆ ਸੀਗਾ ਕਿ ਜਿਵੇਂ ਜਿਵੇਂ ਸਾਈਜ਼ ਆਫ ਆਰ ਇਨਕਰੀਜ਼ ਕਰਦਾ ਜਾਂਦਾ ਹੈ, ਉਵੇਂ extent of hydrogen bonding goes on reducing. No doubt the phenols are polar in nature, but since the size of R, see this phenyl group is here equivalent to our R group there. If the size of the R is increasing, then the extent of hydrogen bonding also decreases. Therefore the phenols also have less hydrogen bonding with water, and therefore they are less soluble in water. Some books write it even as phenols are insoluble in water. The reason is simple. Although the phenols are capable of forming a hydrogen bonding with water because they are polar in nature, but the hydrogen bonds formed between the hydrogen of water and oxygen of phenol is less, because phenols are bigger in size. Therefore the extent of overlapping is reduced, and thus the phenols are less soluble in water. I repeat here, some books even write that phenols are insoluble in water. Then next is this, also we will study that phenols are acidic in nature. Phenols are acidic in nature. they react with a strong base as written on the screen, that phenols reacts with acids and dissolves in 5% of NaOH. 5% NaOH ਨਾਲ phenol ਜਿਹੜੇ ਹੈਗੇ ਆ phenols react ਕਰ ਜਾਂਦੇ ਆ, but they do not react with 5% NaHCO3. NaHCO3 is a weak acid. So that is why this weak acid is not a weak base, sorry, NaHCO3 is a weak base. So a phenol ਦੇ ਵਿੱਚੋਂ hydrogen ਨੂੰ extract ਨਹੀਂ ਕਰ ਪਾਉਂਦੀ. This is what we say, that phenols are weaker acid than carbonic acid and do not dissolve in 5% NaHCO3. See, this is again the important thing which I am talking about, the hydrogen bonding. This hydrogen bonding, when I take intermolecular hydrogen bonding and intramolecular hydrogen bonding, in case of this orthonitrophenol, the intramolecular hydrogen bonding exists, whereas in case of paranitrophenol, the intermolecular hydrogen bonding exists. See how it happens. Let me show you. I am first drawing the orthonitrophenol. Observe the dotted line between the hydrogen and oxygen. This is the hydrogen bonding existing in between the molecule of a orthonitrophenol. Since the hydrogen bonding is existing in between the molecule only, inside the molecule only, that is why we say it is a intramolecular hydrogen bonding. Whereas in other case, when I talk about the paranitrophenol, it is okay beta, in this case I am see in case of paranitrophenol, which is this one, in which I am completing the ring, which is this one, ਜਿਸ ਦੇ ਵਿੱਚ ਮੈਂ ਹੁਣੇ ring complete ਕੀਤੀ ਹੈ. ਇਸ paranitrophenol ਦੇ ਵਿੱਚ you have a intermolecular hydrogen bonding, which is this one. See my pen moving, and since the two molecules are attached with a strong hydrogen bonding, therefore the boiling point of the paranitrophenol is more than the orthonitrophenol. This is orthonitrophenol. I hope this is clear. And this is paranitrophenol. Okay, is it clear? So paranitrophenol ਦੇ ਵਿੱਚ intermolecular hydrogen bonding ਹੁੰਦੀ ਹੈ, ਜਿਸ ਕਾਰਨ ਉਸ ਦਾ boiling point increase ਕਰ ਜਾਂਦਾ ਹੈ, and it is or it can't be distilled by steam, whereas orthonitrophenol is a steam volatile. Sometimes one time this was asked, which out of the two isomers is a steam volatile. So orthonitrophenol, which have lesser boiling point, is a steam volatile, and paranitrophenol is not a steam volatile. Okay, beta. Next, let us take the methods of preparation. So first preparation is from diazonium salt. When we add water simply in this is N2 positive. We didn't write it down here, Cl negative. To complete it, you can write down here Cl negative. So this is the benzene diazonium chloride, ਦੇ ਵਿੱਚ ਜਦੋਂ ਅਸੀਂ simply water ਪਾਈਏ in the presence of acid, this gives us phenol plus N2 plus HCl. If we write it down here as Cl also, then it will be plus N2 plus HCl. So diazonium salts are again a very good synthetic tools to prepare aromatic compounds having different functional groups. Second is by the alkali fusion of sulfonates. This is when we have this benzene sulfonic acid, sodium salt of benzene sulfonic acid is reacted with a base at 300 degrees centigrade. This gives us ONA, and on acidification this gives us a preparation of phenol. So these two are very simple preparations. First is from diazonium salts and another one is from sodium salts of benzene sulfonic acid. The third preparation is from cumene, which is an important one for us. That is when we react this benzene with propene, simple of Friedel-Crafts alkylation in the presence of anhydrous AlCl3, we have here this is what we called as cumene, जिस तो ਅਸੀਂ prepare करना चाह रहे हैं अपना phenol. Then on oxidation simply ਜਦੋਂ ਅਸੀਂ ਇਹਨੂੰ air ਚ expose ਕਰਦੇ ਹਾਂ ਬੇਟਾ, this gives us a peroxide preparation. This is prepared, a peroxide preparation occurs, and this on simply heating or you can say in the sunlight, this decomposes into phenol and a important byproduct named as acetone. So from cumene you can simply prepare phenol by these steps. First, convert benzene by reacting it with propene. This is propene, this is benzene, and in the presence of anhydrous AlCl3 they will convert into cumene, and cumene on oxidation gives a peroxide preparation, intermediate one, and this peroxide on simple heating or in the presence of sunlight decomposes into phenol and a important byproduct named as acetone. I hope this is clear to everybody. Now let us take another one, Dawes process. This Dawes process is an example of simply a nucleophilic substitution reaction of alkyl halides, aryl halides, sorry, as ਜਿਵੇਂ ਕਿ ਅਸੀਂ ਪੜ੍ਹਿਆ ਸੀਗਾ ਬੇਟਾ ਕਿ aryl halides do not show the nucleophilic substitution reactions due to resonance, inductive effect, and all other different reasons, and therefore this also here I put this, X can be chlorine or bromine. Since this does not go nucleophilic substitution reactions easily, therefore we have to produce some drastic conditions. Just for example, if we have high pressure and temperature around approximately 623 Kelvin temperature and 300 atmospheric pressure, and we put a NaOH, aqueous NaOH into it, then the reaction will occur. ਜੇ ਅਸੀਂ high temperature ਤੇ high pressure the conditions apply नहीं करांगे, then the reaction will not occur. Reaction will occur only if we provide extra temperature and pressure. By extra I mean we have to apply high temperature and high pressure. So this I wrote it here as 623 Kelvin and 300 atmospheric pressure. Then this forms a nucleophilic substitution occurs, and this forms sodium ion of phenoxide ion or sodium phenoxide. This is named as sodium phenoxide. This sodium phenoxide on acidification gives us simply OH plus Na positive. So this is how you can prepare a phenol from Dawes process. The third preparation written is by the decarboxylation reactions. ਆ ਸਾਰੀ ਦੀ ਸਾਰੀ decarboxylation reactions ਬੇਟਾ ਤੁਸੀਂ +1 ਦੇ ਵਿੱਚ ਪੜ੍ਹੀ ਹੈ for the preparation of ethane from ethanoic acid or from propanoic acid. So this is, let us see how. This I am writing here. I hope you will name it as what is the name of this? This is simply a salicylic acid. So when we add a metal into it or a base into it, let us say NaOH, or you can simply add a metal, the base nahi pani beta, then it will form COONA. As you know that metals reacts very easily with the acids, therefore we have a sodium salicylate. Now when we do react this with soda lime, that is NaOH and CaO, this is soda lime, also properly known as sometimes that this is a soda lime reaction. Instead of here this benzene ਦੀ ਥਾਂ ਤੇ ਤੁਸੀਂ ਕੋਈ R ਵੀ ਰੱਖ ਸਕਦੇ ਹੋ, ਜਿਹੜੀ ਕਿ ਤੁਸੀਂ ਆਮ ਆਪਣੀ +1 ਵਾਲੀ ਕਿਤਾਬਾਂ ਦੇ ਵਿੱਚ ਪੜ੍ਹਿਆ ਸੀਗਾ during the preparation of alkanes. Then this will simply disappears, COONA group will simply disappears, plus Na2CO3, this will be formed. Okay, so again here we have a preparation of this phenol is done. So phenol, for the preparation of phenol we have 5 main methods which we discussed here, that is, I repeated, from diazonium salts, from benzene sulfonic acid, from cumene, from aryl halides with the help of Dawes process, and then decarboxylation of sodium salicylate. Let us, before proceeding further, let us try to differentiate between the alcohols and phenols. ਜਿਵੇਂ ਕਿ ਮੈਂ ਤੁਹਾਨੂੰ ਦੱਸਿਆ alcohols ਤੇ phenols ਦੇ ਵਿੱਚ ਕੀ difference ਹੈ, ਜੇਕਰ ਅਸੀਂ difference ਲੱਭਣ ਚੱਲੀਏ, by structure the difference between the alcohols and phenols is that in case of alcohols we have aliphatic hydrocarbons attached with it, and see this is, I have here, I am writing RX, this is the aliphatic one. Same beta ਜਿਹੜੇ ਤੁਸੀਂ ਉੱਥੇ ਪੜ੍ਹੇ ਸੀਗੇ, ਮੈਂ ਜਾਣ ਕੇ X ਲਿਖਿਆ, ਜਿਹੜੇ ਕਿ ਤੁਸੀਂ alkyl halides ਵਾਲੇ ਕੇਸ ਦੇ ਵਿੱਚ ਪੜ੍ਹੇ ਸੀ ਤੇ aryl halides ਵਾਲੇ ਕੇਸ ਦੇ ਵਿੱਚ ਪੜ੍ਹੇ ਸੀਗੇ. This is, I am writing here as aryl group. ਜੇ ਤੁਹਾਨੂੰ ਯਾਦ ਆਉਂਦਾ ਹੋਵੇ ਤਾਂ ਇੱਥੇ this is the aryl group. ਉੱਥੇ ਵੀ ਬਹੁਤ ਸਾਰੀ properties ਦੇ ਵਿੱਚ difference ਆ ਗਿਆ ਸੀਗਾ due to the presence of aryl and alkyl group. Same is here. The difference in the properties will arise due to this and this group. Means on the X, instead of X we can have here OH group, and here also we can have OH group. Instead of this X we can have this OH group. When we have OH group, then it will become a alcohol, and when we have OH group in case of aryl, then it will become a phenol. There will be a too much difference between the properties. Some of the differences are on your screen, that is, alcohols will react with HX. They simply, alcohols reacts with HX and forms alkyl halides, okay, whereas phenols can't react with alkyl HX halogen acids because they do not show the nucleophilic substitution reactions, whereas alcohols can show the nucleophilic substitution reaction. Similarly, PX3 alcohols can react with the phosphorus halides, whereas phenols can't react with the phosphorus halides. Okay, ਆ ਜਿਹੜੀਆਂ ਅਸੀਂ HX and PX3 ਦੇ ਨਾਲ, PCl3 ਦੇ ਨਾਲ ਜਾਂ PBr3 ਦੇ ਨਾਲ ਅਸੀਂ ਰਿਐਕਸ਼ਨਸ ਕੀਤੀਆਂ ਸੀਗੀਆਂ, ਜਾਂ SOCl2 ਦੇ ਨਾਲ ਰਿਐਕਸ਼ਨਸ ਕੀਤੀਆਂ ਸੀਗੀਆਂ, ਫੀਨੋਲਸ ਨੂੰ SOCl2 ਦੇ ਨਾਲ ਰਿਐਕਟ ਨਹੀਂ ਕੀਤਾ ਜਾ ਸਕਦਾ ਜਾਂ PCl3 ਦੇ ਨਾਲ ਰਿਐਕਟ ਨਹੀਂ ਕੀਤਾ ਜਾ ਸਕਦਾ, because they simply do not show the nucleophilic substitution reaction. Similarly, in case of phenols, the dehydration is not possible, which in case of alcohols can be done simply with the help of acid or with the help of P2O5 or with the help of Al2O3. ਅਸੀਂ dehydration ਦੇ 3-4 methods ਕੀਤੇ ਸੀਗੇ, whereas in case of phenols we can't do the dehydration. Yes, alcohols are acids, phenols are acids. Phenols are more acidic than alcohols. This we will study. And ester formation, similar reaction in between the alcohols and phenols. And the oxidation, last one is oxidation. Oxidation of alcohols gives us aldehyde, ketone, and lastly a acid. Alcohol first changes into aldehyde or ketone, and then it changes into a acid, depending upon the type of oxidizing agent used. But phenols do not oxidize normally. No doubt, oxidation of a phenol is possible by a strong oxidizing agent into ketones, but normally they do not oxidize. Let us see some of the reactions. First of all, I will try to take the reactions of phenols with as an acid, where phenols will act as a acid. Then we will study the ether formation, how phenols can form ethers. Then the main characteristic properties of a phenol is electrophilic aromatic substitutions, that is ring substitution reactions, and then we will take some of the special reactions of the phenols. So first of all, let us take phenols acts as a acid. Phenols are a strong acids, not a strong acid, but they are, you can see the list or you can take the list from the slides. So phenols have good, it is in between, it is more acidic than water but less acidic than carbonic acid. So it is a good, see here we have a phenol written in a red. So phenol acids reacts with metals, metal displaces hydrogen from the acids. So similarly metal here we taken as a sodium, sodium replaces the hydrogen from the phenol and changes into sodium phenoxide, plus hydrogen is liberated. When we have a base, then it reacts with a base and forms again a salt formation and a acid. Okay. See here also we have taken the same slide. This is a water soluble and this is water insoluble. As I stated you also that this is water insoluble because it does not form hydrogen with water much effectively. ज़्यादा इफेक्टिवली आ हाइड्रोजन बॉन्डिंग वाटर दे नाल नहीं बना पांदा क्योंकि क्योंकि एज द साइज जिहड़ा इहदे विच रिंग दा साइज है दैट इज बिगर वन एंड विच कॉजेज द स्टेरिक हिंड्रेंसेस. सो इट इज लेस soluble in water, or we can write it insoluble in water, whereas the salt formed here, sodium phenoxide, is a water soluble one. And as stated you earlier also that see with the weak base it can react only with a strong acid, strong base, but it can't react with weak base. Therefore we have no reaction of a phenol with NaHCO3. This reaction we can use to distinguish between the phenols and alcohols, whereas alcohols being a weak base, they react with a weak base and form a salt. Salt formation occurs. But in case of, when we take the case of phenols, it does not react with sodium bicarbonate and does not forms any reaction. We have a comparison here with phenols and acids. See, phenols are also water insoluble, these are also water insoluble. See beta, carboxylic acid, here I am making a point clear that carboxylic acids up to 4 carbon atoms are no doubt shows solubility in water, but higher carboxylic acids are insoluble in water, and also the benzoic acid also shows very limited solubility in water, very limited solubility in water. And in NaOH, phenol is soluble, and this is means both acid and phenols reacts with strong base, but with a weak base phenols do not react, whereas carboxylic acids reacts with a weak base also. So this as I stated, NaHCO3 solution is used to distinguish between phenols and carboxylic acid, and also with phenols and alcohols. Let us see how we can determine the acidic strength. Acidic strength, as you studied in +1, के depend करती है dissociation constant ते, जिन्हों असी Ka दे नाल represent करते हैं. एक base water दे नाल react कर रही है on the graphics, ठीक है, it forms H3O positive and base the negative बचेगा उन्हें क्योंकि base, ठीक है, and this forms Ka will be दोनों the products the, these are the products, इन्हां नूं multiply कर दो आपस च divided by this base. We left this water because this is an excess, so ਅਸੀਂ ਉਹਨੂੰ ਛੱਡ ਦਿੰਦੇ ਹਾਂ. See, ROH ਦੇ ਵਿੱਚ dissociation constant is around 10 raised to power minus 16 to 10 raised to power minus 18, and S ਦੇ ਵਿੱਚ it is around 10 raised to power minus 10. So from the dissociation constant it is very much clear that alcohols are stronger acids than alcohols. Okay, also I am going to link this Ka with pKa value also. Lesser the pKa value, write it down, lesser the pKa value, stronger is the acid. I repeat, lesser the pKa value, stronger is the acid. Ka the value beta je ज़्यादा होवे, more value of Ka means stronger acid. So एराइल एल्कोहल्स के केस दे विच pKa की वैल्यू घट होंदी है, एल्कोहल्स की वैल्यू ROH की वैल्यू pKa के केस दे विच ज़्यादा होंदी है। जिन्नी ज़्यादा pKa की वैल्यू होएगी उन्ना वीक एसिड होएगा। ओके, सो कई बार तुहानू Ka दे नाल एसोशिएट करके क्वेश्चन आ जाता है, कई बार pKa दे नाल एसोशिएट करके क्वेश्चन आ जाता है। नाउ लेट अस ट्राई टू स्टडी दैट व्हाई phenols आर मोर एसिडिक दैन alcohols. Okay, see, alcohols when goes in water, it forms H3O positive and RO negative. Here also this and forms this, and when we draw the resonating structures of alcohol, it forms this. Phenol दी जड़ी resonating structures है बेटा वो आ draw होंगियां OH OH, simply दो resonating structures, or we can have in between also, which I can draw for you on the board. You will then guess which is more stable. These two electrons comes here. OH group has plus R effect. It donates the electrons to the ring. So it has a plus R group. Therefore, OH group is a ring activating group. And you will see when I draw the resonating structures of this, you will see that it is ortho and para directing for a electrophilic substitution reactions. Move the electrons ahead. Now this electron will go in and this will come out, and we have another resonating structure as then this goes in and this goes back. मैं बेटा पूरी 5 स्ट्रक्चर्स ਇਹਦੀਆਂ ड्रॉ कर ਦਿੱਤੀਆਂ phenols ਦੀਆਂ ਵੀ resonating structures, and also you will see in case of phenoxide also there are 5 resonating structures, and in case of phenols also there are 5 resonating structures. See, I am numbering some of the structures here, that in case of a phenol it is 1 2 3 4 and 5. Now in case of a phenol, the structure number 2 3 and 4, they contribute very less, towards the resonating structures, because this case the positive charge is with the more electronegative element, that is with the oxygen. So जदों ਇਹੋ ਜਿਹਾ केस ਹੁੰਦਾ है कि positive charge ਤਾਂ ਆ ਜਾਏ ज़्यादा electronegative element ते negative charge चला जाए less electronegative element दे, then the structure do not contribute towards the resonance stabilization. So effectively phenol दियां 2 resonating structures है ते phenoxide दियां 5 resonating structures है, which are on your screen. So these 5 resonating structures makes the phenoxide ion, ARO negative ion, more stable, and therefore as the less energy होने करके the equilibrium shifts towards the right in this case. In the second equation, in case of phenols, the equilibrium shift towards the right, and therefore the phenols loves to live in phenoxide ion and they are stronger acid, whereas in case of alcohols the equilibrium shifts on to left hand side and they are less acidic. This we can explain with the help of inductive effect also, because as you know the R has a plus I effect, it is an electron donor, therefore increases the electron density on the oxygen, whereas phenols de which a phenyl ring is have a minus I effect, therefore it attracts the electron towards itself and makes the ring or the phenol to release H positive ion more easily. Therefore, phenols are more acidic than alcohols. We will take the reactions, acidic reactions of phenols after a little break.